Today's lesson is lesson number 5, combining like terms, and this is going to be the first day we're practicing our skill. So in order to combine like terms, we need to review things we've already learned, and so we're going to start with a warm-up that I want you to do on your own. Use our distributive property to write an equivalent expression for this first problem here. And then for the second problem, I want you to factor. So those are notes number 3 and number 4, so pause the video, go back in your notes, figure out these two problems, and then come back to check your answers. Okay, so you should have done these first two on your own. Remember, distributive property, we have to take our value outside, and we need to multiply it with every term inside. So Miss Morose always goes, pew, pew. We need to take this 5 and share it with everything on those parentheses. So we're going to take 5 times my first arch, which is x. 5 times x is just 5x. When you have one number and one variable multiplied, we just smush them together. And then my second one, pew, is 5 times positive 5. So 5 times 5 is plus 25. And here is my new expression. Now for that second example, we needed to factor. So factoring is when we take out what do they have in common, what's their GCF, and then we write the leftovers in parentheses. So 3 and 9, they both divide by 3. So that's what they have in common. So if I take away 3 from each of these, so I'm dividing by 3, my 3's cancel here. I have a leftover x plus 9 divided by 3 is a leftover 3. So when I factor, I take out what they have in common. That's my first thing outside. And then what's left over is on the inside. Now today we're going to talk about like terms and putting more terms together to keep simplifying. So looking at our problem, how many do we have of each? So if we look at this first example, I see I have 1, 2, 3, 4. So I have 4 solid hearts. I have 2 white hearts, and I have 2 teddy bears. So we need to write this with symbols as it appears. And so in order, I want to write down what we have. We have a red heart. We have a white heart. I have a red heart. And I have a teddy bear. I have a red heart, a white heart, and a teddy bear. So my symbols that I used were variables. R for the red hearts, W for the white hearts, and T for the teddy bears. And so what we want to do is we want to write this with symbols with the pictures that are combined. So put together the same pictures, the things that are alike. So I have those 4 red hearts. I chose R for my red heart. So I could write 4, oops, roll use green, 4R. That shows me my 4 red hearts. Then I had 2 white hearts, so I had used W and W. So I could add that to my problem as 2 W's. And then I have 2 teddy bears. So I have a T plus another T. So I have 2 T's that I can add to my expression. Here is our problem. And then down here is our simplified problem. And this put all my like terms together. Notice everything that was the same letter got put together. So when I talk about like terms, which is our vocabulary for today, like terms are the exact same variable with the same power. Okay, so they have to be really identical. Like terms could also be just numbers and other numbers. So anything that's exactly the same can be put together. So if we look at our first problem down below, it says circle the like terms. I have 3x, 5y, 4x, and 5x squared. I'm looking for something with the same variable and the same power. The only things that match would be 3x and the 4x. They both have the variable x. I see this one has an x too, but it has a different power, so that's not the same. And this one doesn't even have the same variable, so it's not the same. The 3x and the 4x are what we could put together. Now, I want you to try this next one on your own. Circle the like terms down below, pause the video, answer the problem, then come back. If you looked at these four, you should have circled 5y and 5y. And when we talk about combining like terms, which you'll hear me say a lot, we combine like terms by adding or subtracting the coefficients. Remember, coefficient is the vocabulary word. It's the number in front of the variable. So in the problem you just did, our coefficient is 5 for both of those two that we circled. So we have some examples where we need to put our like terms together. If I look at this first example, 10s plus 10s plus 8s minus 10s. Notice they all have the exact same variable, so I need to put them all together. So I only do 2 at a time. 10s plus 10s, that's 20 s's because I added 10 and 10. Plus 8s minus 10s. 20 s's plus 8 s's is 28 s's minus the 10s. I finally can finish this by putting those together. 28 minus 10, 18s. In this case, I was able to put everything together to get only one term for my answer. Now in our next problem, 3x plus 4y plus 4x plus 20y. Put the things with the same letters or variables together. So I have a 3x, and take the sign out of it, plus 4x. So those are the same because they both have an x, and I'm adding because of this plus sign right here. So 3x's plus 4x's, that's 7x's total. And I can also put my y's together. I have 7y's plus 20y's is 27y's, and it's positive, so I'm plussing those two things together. Make sure that you always have a sign between your terms. Now when I look here, I have an x here and a y here. They're not the same, so this is my answer. I can't put it together anymore because those are not the same. They're not alike, so do not put those things together. Next, we have 12x plus 3y minus 4x plus 6y. So I see an x and an x. Because you take the sign in front, we are minusing. So because these are being subtracted, I'm going to start with the 12 and I'm taking away 4. So 12 minus 4 is 8x. And then I have to go to my other term. I have y. So I have a plus 3, so it's a positive 3, plus 6. So 3 plus 6 is 9y's. And they're being added together. And then like I said before, x's and y's are not the same. So we're not going to put them together. But we have a sign in the middle, so that's good. But they're not the same, so we can't do any more work. We simply say, this is my answer. Then we have our last one. When I think about what is the same, so I have a 4x squared, and I see another, here's another x squared. So I'm adding, because there's a plus in the middle, so 4 plus 5 is 9, copy your variable. Then I have a 3x, and here's another x, so I'm going to take 3x minus 2x. So 3 minus 2 is 1x, so I'm going to say plus 1x. And then I see I have a minus 6y. It doesn't have anything to go with, so I just rewrite it, minus 6y. Now just remember, even though these both are x's, one has a power of 2 and one does not, so they're not the same. We cannot put them together. So this whole thing here is my answer. Also remember, anytime you see a variable that's just by itself, so I have just x or just y, it's the same as saying 1x or 1y. So keep that in mind as you work through problems today. And lastly, I wrote 3 problems for you. So what I would like you to do is copy these 3 problems onto your paper, then pause the video and simplify them on your own. After you think you have the answers, come back and look at my answers to compare. So the answer for number 1, I put my x's together. 6x minus x is really minus 1x. So I snuck a 1 in, so I remembered. And it's 5x. And then when I put my y's together, I got plus 7y. Those are not the same, so that's simply my answer. For number 2, 12x squared was just by itself, but I was able to put my numbers or constants together, so I was able to add 8 and 12 to make 20. And the last one was definitely our challenge problem. So I started with distributive property, pew pew, and I multiplied, so I ended up with a 2x minus 8, and then I recopied that plus 6. And then when I did that, I noticed I was able to put my numbers together, but this is where it's tricky because this is 7th grade. We were at negative 8, and then I added 6. And when I put those together, I'm still in the negative, so it's negative 2 or minus 2. And that's a tricky problem, so if you got that right, very nice work.